Hello, welcome. Today we're going to do stacks and its operations. This is the data structures and applications topic. Let's get started. So the content or the index for this presentation is the introduction of stacks, the basic operation of stacks, types of stack, application of stacks, the implementation of stacks, and the advantages and disadvantages of stacks. Introduction. What is stack? A stack is a linear data structure in which the insertion of a new element and removal of an existing element takes place at the same end, represented as the top of the stack. To implement the stack, it is required to maintain the pointer to the top of the stack, which is the last element to be inserted because we can access the element only on the top of the stack. And therefore, last in first out, this strategy states that the element that is inserted last will come out first. You can take a pile of plates kept on top of each as in real life example. The plate which we put last is on the top, and since we remove the plate that is at the top, we can say that the plate that was put last comes out first. The basic operations on stack. In order to make manipulation in a stack, there are certain operations provided to us. Push to insert an element into the stack, pop to remove an element from the stack, top returns the top element of the stack, is empty returns true if stack is empty, else false, size returns the size of the stack. The operations. Push adds an item to the stack is full, then it is said to be an overflow condition. Pop removes an item from the stack. The items are popped in the reversed order in which they are pushed. The stack is empty. It is said to be in underflow condition. Top returns the top element of the stack is empty. Returns true if the stack is empty, else false. Types of stacks. Fixed size stack. As the name suggests, a fixed size stack has a fixed size and cannot grow or shrink dynamically. The stack is full and an attempt is made to add an element to it, an overflow error occurs. If the stack is empty and an attempt is made to remove an element from it, an underflow error occurs. Dynamic size stack. A dynamic size stack can grow or shrink dynamically. When the stack is full, it automatically increases its size to accommodate the new element, and when the stack is empty, it decreases its size. This type of stack is implemented using a linked list as it allows for easy resizing of the stack. More types of stack. In addition to these two main types, there are several other variations of stack, including infix to postfix stack. This type of stack is used to convert infix expressions to postfix expression. Expression evaluation stack. This type of stack is used to evaluate postfix expressions. Recursion stack. This type of stack is used to keep track of function calls in a computer program and to return control to the correct function when a function returns. Memory management stack. This type of stack is used to store the values of the program counter and the values of the register in a computer program, allowing the program to return to the previous state when a function returns. Balanced parentheses stack. This type of stack is used to check the balance of parentheses in an expression. Undo redo stack. This type of stack is used in a computer program to allow users to undo and redo actions. Applications of stack. Infix to postfix, prefix conversion, redo undo features at many places like editors, Photoshop, forward and backward features in web browsers, used in many algorithms like Tower of Hanoi tree, transversal, span problems, and histogram problems. Backtracking is one of the algorithm design techniques. Some of the backtracking are the Naito problem, include problems, and examples. In graph algorithms like topological storing and strongly connected components, in memory management, any modern computer uses a stack as a primary management for running purpose. Each program that is running in a computer system has its own memory allocations. String reversals, also another application of stack. Here, one by one, each character gets inserted into the stack. The first character of string is on the bottom of the stack, and the element of the string is on the top of the stack. After performing the pop operation on the stack, we get a reverse string in reverse order. Stack also helps in implementing function calls in computers. The last call function is always compiled first. Stacks are also used to implement the undo and redo operations in text editor. More application, function calls and recursion. When a function is called, the current state of the program is pushed onto the stack. When the function returns, the state is popped from the stack to resume the previous function's execution. Undo and redo operations. The undo and redo feature in variation applications uses stacks to keep track of the previous actions. Each time an action is performed, it is pushed onto the stack. To undo the action, the top element of the stack is popped and the reverse operation is performed. Expression evaluation. Stack data structure is used to evaluate expressions, infix, postfix, prefix, notation, operators, and operands are pushed onto the stack, and operations are performed based on the stack's top element. Browser history. Web browsers use stacks to keep track of the web pages you visit. Each time you visit a new page, the URL is pushed onto the stack, and when you hit the back button, the previous URL is popped from the stack. Balance parentheses. Stack data structure is used to check if parentheses are balanced or not. An opening parenthesis is pushed onto the stack, and a closing parenthesis is popped from the stack. If the stack is empty at the end of the expression, parentheses are balanced. Backtracking algorithms. The backtracking algorithm uses stacks to keep track of the states of the problem-solving process. The current state is pushed onto the stack, and when the algorithm backtracks, the previous state is popped from the stack. Advantages of stack. Easy implementation. Stack data structure is easy to implement using arrays or linked lists, and its operations are simple to understand and implement. Efficient memory utilization. Stack uses contiguous block of memory, making it more efficient in memory utilization as compared to other data structures. Fast access time. Stack data structures provides fast access time for adding and removing elements as the elements are added and removed from the top of the stack. Helps in function calls. Stack data structure is used to store function calls and their states, which helps in the efficient implementation of recursive function calls. Supports backtracking. Stack data structure supports backtracking algorithms which are used in problem solving to explore all possible solutions by storing the previous states. Used in compiler design, stack data structure is used in compiler design for parsing and syntax analysis for programming languages. Enables undo and redo operation. Stack data structure is used to enable undo and redo operation in various applications like text editor, graph design tools, and software development environment. Disadvantages of stack. Limited capacity. Stack data structure has limited capacity as it can only hold a fixed number of elements. The stack becomes full, adding new elements may result in stack overflow, leading to the loss of data. No random access. Stack data structure does not allow for random access to its elements, and it allows for adding and removing elements from the top of the stack. To access an element in the middle of the stack, all the elements above it must be removed. Memory management. Stack data structures uses a contiguous block of memory, which can result in memory fragmentation if elements are added and removed frequently. Not suitable for certain applications. Stack data structures is not suitable for applications that require accessing elements in the middle of the stack, like searching or sorting algorithms. Stack overflow and underflow. Stack data structure can result in stack overflow if too many elements are pushed onto the stack, and it results in stack underflow if too many elements are popped from the stack. Recursive function calls limitations. While stack data structure supports recursive function calls, too many recursive function calls can lead to stack overflow, resulting in termination of the program. Thank you so much. I hope you understand.